is just one little area of percentages. It's no different basically than percentage change. Okay, because what's happening is you're going to have two different values and you're going to try and find one as a percentage of the other. Okay, so it's just a fancy way of looking at percentage change. So what happens is that we have what we call an experimental or observed value.
I have a booklet about it.
Say it.
I have a booklet about it, but I'm not sure the part. It's in the second last page.
Next one. Okay, so we've got our experimental or observed value. Take away the true value divided by the true value. Okay, so it's a little bit different in that we're always saying we divide by the original value. Yes, remember when we're doing percentage change, we do the difference divided by the original. Well, you're going to find the observed subtract the true divided by the true value. Now, you might think, well, what's she on about? What is she rounding? So, can you write down a guess for how tall I am in centimeters? Okay, so you're going to write down a number. Now, I'll give you a clue. This is approximately what? What would you say this height here is?
12
This here is 12 centimeters.
100.
Yes. Okay, we want centimeters. So what am I giving you that as a clue as? What do you think from the ground up to here must be around? 100. Why is that about 100? It's about a meter, yes? You're imagining a meter ruler, yes? So that's probably about 100 centimeters. So I'm going to be more than 100. I'll give you a clue for that. Okay, I would suggest that a door is often around 200 centimeters. Okay? So I'll help you out there because I've had some ridiculous.
Yeah, 175. 175.
I said, holy shit, ladies. I said, what is it? Interesting. Okay, so we've got a number.
Yeah.
Okay. I probably should know how to write, shouldn't I?
You don't know.
I think I'm 176.
I said 175.
Alright, so you're going to write here now, Miss Harrison's true height is 176 centimetres.
I was so good.
Okay, no, so wait a minute. In this gap here, you are supposed to have written your guess, yes?
Alright, try doing it.
So your guess, no, you cannot do a new guess. You stick with your 300 centimetres.
How did you say 300?
She said I was
Door was 200.
She said out of 3 meter sticks, apparently.
That's like Mr. Daddy. No, it's not.
No, he's not. He's 7 foot. Anyway, so, what am I saying here?
178.
Right, no, I said 176. So we've got your guess here, our true height here. So we're going to calculate the percentage error. So we're going to use that formula. So your value, whatever you had written down, you're going to subtract 176.
Why do we do the one now?
Underneath here,
Okay.
with this gap. So you're going to have your guess, subtract 176, and then what are we going to divide that by?
By 176.
The true value, which was 176. Okay. Now, as it says here, negative sign in your answer means that your estimate was too low. So if you've got anything below 176, you should have a negative sign. Yes? If you've got a positive sign, then it means your guess was too high. Now, sorry, I only got through half the formula. So you've done your value, subtract the true value, divided by the true value, and then you multiply it by 100. Why are you going to multiply it by 100? Why do you think we're doing that?
To find the percentage?
Yes, because it's the percentage error, not just the error. Okay? So it's the percentage error. So you're going to multiply that value by 100. So what kind of things have we got there? Emily?
84%.
You were wrong by 84%? Oh
I said 184.
I said 183.
Negative 0.5. Look. Wait, I'm not done. I got negative.
That's 70.45. Oh, I thought you said
7.
You said 7, I'm sure, didn't
Yeah,
you?
I got this.
Because I was thinking, no, you said 300. Okay, so we've got around 6.
I got negative
17.
9.
Negative 9.
I got 7.
8.
How did I get 84 if
I
mine was
don't know, I think you could have done something.
Because you only got, I got right under, I got 7%.
You wrote it. So you're going to write that as a percent sign. Now, if you are a good guesser, that value is going to be tiny, whether it's positive or negative. Okay? So if you were a good guesser and you had a round or very close to 176, then that number is going to be small.
I'm very, very confused with my 0 because when I got my answer, my guess was 175,
Yeah?
and so the decimal was 1.568 recurring and 1 recurring, and I don't know how to do that.
I got that too, Hannah. I got negative 0.
I'm so confused.
I got negative 0.56.
8 I'm sorry, I'm going to pause this and try and deal with it. Alright, so some of you are very good guessers, others not so much. Okay, so here's another example. A student weighs a beaker and records its mass as 47.21. The actual mass of the beaker is 47.93. What is the student's percentage error? So, what are we going to start off with here, Sarah?
I'm going to do 47.21, take away 47.93, divided by 47.93 times 100.
Beautiful. Okay, so Sarah has just checked to see which one is the real one, which is her experimental one, and then we chuck that in the calculator. Now have practice putting it in the calculator just the way you see it. Amy, do you have an answer?
Negative 1.52%.
Awesome. Okay. Were they good at guessing to start with? Yes. Or were they good at weighing it? Yes. And this is another thing that we often say. It's like, well, how accurate was someone doing these things? So it's actually they've actually measured it, but sometimes people don't measure very well. They haven't reset their scales to 0. They've looked at the wrong scale on, like for example, if they're measuring, they might have measured in inches and not centimeters, etc., etc. So percentage error is used quite a fair amount in practical situations. Yes, Georgie?
Even if it's like, do you always put the estimate minus from
Yes. Yeah. Yes. And that's where it comes up that if you've got a negative value, it means that you were less than what it should have been. Okay? Emily?
I got negative 1.50.
Yeah, I was just gonna, yeah.
Oh, so who told me negative 1.52? 502. Someone got a bit excited. So it's negative 1. Thank you very much for that. Sarah, you still have that?
Negative.
Yes.
If we wanted, can we just make it 1.5?
Now, that's a very interesting thing. If you round into 3 sig fig, no. Okay? Whilst this is equivalent to that, if you just wrote that, if I wrote this, I should be writing 3SF. If I wrote that, then I would assume that the answer is just literally negative 1.5. But writing this tells me and someone else that there are more digits, but that those digits are less than 5. Does that make sense?
If they don't tell you, just write it to 3 sig.
Yes, let's go with the if you're not told, always 3 sig fig. Okay? Alright, so here's some more examples. I'm going to let you have a go at these ones on here. You've got the formula there, you've got your calcs. And then once we've done that, we're going to then go back and work on some of those questions that I gave you yesterday. Okay? We all good?
Yeah.